Welcome to Get Your FRQ On. This question is from the 2013 exam. It's question 4. In the question stem, we are provided with a graph of f prime and a little bit of given information. For example, f of 8 is 4. There are some points on the graph that give us some specific information, and the graph also contains the areas of some bounded regions between the graph and the x-axis, which we will need for other parts of this question. For part A, we are asked to find all values of x between 0 and 8 for which f has a local minimum and to provide justification. Because we have the graph of f prime, we want to make sure that our justification relies either entirely or mostly on what we are given, and we are given the graph of f prime. So in order to determine where f has a local minimum using f prime, we need to know where f prime is equal to 0, where it might be undefined, and then what are the signs? Does it change sign? Is it going to be a maximum or a minimum? We have to be able to determine that. Right? We're given in the question stem that f of x is twice differentiable. Now this means that f of x and f prime of x are both going to be continuous functions. Right? Under those conditions, the graph of f could have a local minimum at an endpoint of an interval or somewhere in the interval where the derivative is either 0 or undefined. If f prime is equal to 0, then f prime must also change sign from negative to positive in order for this to represent a local minimum. If it's the opposite, switching from positive to negative, it would be a local maximum. That is not what we are looking for. We're also given an open interval, so we don't need to consider the endpoints. We don't need to consider 0 or 8. And since f prime is continuous, we know that there's not going to be any points in that interval from 0 to 8 where the derivative is undefined. So, justifying our conclusion based on what we are given, which at this point is pretty much just the graph of f prime, we can see that f prime of 6 is equal to 0, so it meets that requirement, and f prime of x changes sign from negative to positive at x equals 0. So, we can conclude from this that the only local minimum of f of x occurs at x equals 6. For part B of this question, we are asked to determine the absolute minimum of f on the closed interval 0 to 8 and provide justification. Now, because we're looking for an absolute minimum, we have to evaluate the endpoints. It is a closed interval. All right, so from part A, all right, we already know that f of x has a local minimum only at x equals 6. We don't know the value yet, but we do know that there is only one local minimum. It happens at x equals 6. So this function f of x can have an absolute minimum only at x equals 6 or at one of the endpoints x equals 0 or x equals 8. All right, so now all we really have to do is evaluate f of 6, f of 0, and f of 8 to check to see which one is the smallest. All right, we are given in the stem that f of 8 is equal to 4. Okay, so f of 8 is equal to 4. We just have to find the other two and compare to 4. We can find f of 6 and f of 0 using the fundamental theorem of calculus. All right. On the graph of f prime, we are given specifically and explicitly the areas of the different regions bounded between f prime and the x-axis. So even though we're going to be using definite integrals, we actually have all those areas provided for us. So by the fundamental theorem of calculus, f of 6 would have to be f of 8, which we know is 4, minus the integral from 6 to 8 of f prime of x dx. Right? We are given on the graph that that area is equal to 7, and 4 minus 7 is negative 3. So f of 6 is negative 3, which is lower or less than 4. So, at this point, f of 8 cannot be the absolute minimum. We can also determine f of 0 using the fundamental theorem of calculus. F of 0 is 4 minus the integral from 0 to 8 of f prime of x dx. And by adding up all those areas, the integral from 0 to 8 is 12, and 4 minus 12 is negative 8. So we can conclude from this that the absolute minimum value of f on the closed interval from 0 to 8 is the value negative 8. It occurs at x equals 0. For part C of this question, we are asked to determine what x values between 0 and 8 is the graph of f concave down and also increasing, and to provide an explanation. Well, the graph of f will be both concave down and increasing when f prime is decreasing but also positive. Right? If f prime of x is decreasing, we know that the second derivative is going to be negative, right? So it'll be concave down. But if f prime of x is positive, we also know that f will be increasing since the derivative is still positive. Right? So all we have to do is figure out where both of those things are true. We have the graph of f prime. So if we check the graph of f prime, we'll be able to see that f would be concave down and increasing over two different intervals. The interval x is greater than 0 but less than 1, and the interval x is greater than 3 but less than 4. In part D of this question, we are defining a new function g of x equals f of x cubed. We're told that f of 3 is negative 5 halves, and we are asked to find the slope of the tangent line to g at x equals 3. Well, in order to find the slope of the tangent line to g at x equals 3, we have to be able to evaluate the derivative of g at x equals 3. In order to do that, we're going to have to use the chain rule to find an expression for g prime. All right, well, by the chain rule, g prime of 3 would be 3 times f of 3 squared times f prime of 3. All right, well, we were just told that f of 3 is negative 5 halves, so we have 3 times negative 5 halves squared times f prime of 3, which we are given in the question stem that f prime of 3 is equal to 4. So if we multiply all that together, we get 75, and therefore we can conclude that the slope of the tangent line to g at x equals 3 is 75.